Algebra 1, number 1.2d. This is part 2 of simplifying expressions. So we have more simplifying of expressions. If you didn't see the 1.2c, you might be very confused and you might want to go back in the playlist. So we multiply factors together to get a product, and 2 times 4 equals 8. The 2 and the 4 are factors, and the 8 is a product. When the only common factor of a numerator and denominator is a 1, the fraction's in its simplest form. It can't be reduced anymore. And simplifying means finding the simplest form. So we have 8 over 12. The factors of 8 are 2 times 4, and the factors of 12 are 3 times 4. This 4 and this 4 cancel out as a 1 because of the identity property. And 2/3 times 1 is 2/3, and we've now simplified the 8/12 as far as we can go. The 2 and the 3 only have 1 as a common factor. The only thing that they have in common would be a 1. 2 times 1 and 3 times 1. So now we know it's simplified as far as it can go. Now, in this one, we had 16abc over 2cab, and they weren't in the same order, but it doesn't matter. This A can be over this A, this B can be over that B, and that C can be over that C as a 1 times 1 times 1. So we just end up with 16 over 2, and that equals 8. So that one equals 8, and that's using the identity property. Now, if you don't know what I'm talking about, it's because you got ahead of yourself, and you should have watched the previous video when we talked about the identity property. So you need to go back to 1.2c, all right? This is part 2 of it. So if we have 9bc, and it's over 11ab, well, there's not another C and there's not another A, but we can cancel out these two B's as B over B. And what we're left with is 9C over 11A, and that's as simplified as it's going to get. See? How about this one? We got 24 times 3PQ over 5 times 9QR. I see a common Q here. 24 can be factored as 3 and 8, and then we can multiply it by the 3 and the P and the Q. And then the 5 can be put down here, and then the 9 can be factored as a 3 and a 3. So now what I see can happen is this 3 cancels out that 3, this 3 cancels out that 3, this Q cancels out that Q, and what are we left with? An 8 and a P is the numerator, and a 5 and an R is the denominator. See that? So we got a 1 and a 1 and a 1. So 1 times 1 times 1 is 1, isn't it? So we got 8p over 5r, and that's as far as we can reduce it, see? We can't say, oh, it's an improper fraction and we're going to fix it. Just leave it as 8p over 5r, all right? So we can cancel out any matching numerator and denominator as a 1. If we've got 6 times 4xy times 3 and 5 times 3x times 2y, even if they're not in the same order, if it's got a numerator or denominator that matches that we can turn it into a 1, it works. So here's the same problem, and I'm just going to do my canceling out over it, okay? So these are identical. So this x can be canceled out with this x. This y can be canceled out with that y, even though they're not over each other. See that? And if you remember from your fractions, this 2 can be canceled out as a 1, and this 4 can be canceled out as a 2. Do you remember when we were multiplying and dividing fractions, how we could cancel out like that? So now we've got 6 times 2 times 3 over 5 times 3. And now this 3 can be canceled out with that 3. What do we have left? We've got 6 times 2 over 5 times 1. See that? We've canceled out the variables and most of the coefficients, and this canceled out as a 1 and a 2. We could have done this as a 1 and a 3, couldn't we have? So now we've got 6 times 2, which equals 12 over 5 times 1, which is 5. And that's our answer, 12 over 5. See? Let's try this one. Here's the original problem, and I expanded the 36 into factors of 3 and 12 because I've got a 2 and a 12 here. So I didn't want to do 6 and 6 because I've got a 12 down here, and I want the factors to match. So that can be a 3 and a 12. So that means this 12 and that 12 can cancel each other out. See how they both have a z? So that z and that z can cancel each other out. And what do we have left up here? A 3xy and a 2 as a denominator, and that's our answer. See? We created identity property 1s that canceled them out. See? We do that a lot in algebra. So now we've got 3STW over 6SUW. So the 3 is a 1 times 3, and the 6 is a 2 times 3, because we want factors that match. And that 3 can cancel each other out. They both have S, so the S's cancel each other out as a 1. And the W's, they both have W's as a numerator and denominator, so they cancel each other out. The only thing that's left is a 1t over a 2u. And if you remember from my previous video, we have a 1 in front of it. It's an invisible 1. We don't have to write that 1. When we just have a t, we can see there's only one t. We don't need to have a 1 in front of it to know there's just one t sitting there. It's when there's two t's that we need the coefficient 2 in front of it to let us know how many there are, or 3 t's or 4 t's. But when there's just one, we can see there's just one, right? So that's more about simplifying expressions. They're going to be very similar to what you'll see in your textbook. I hope this really helps you. And I know this can be very confusing, but we're going to get through this together, okay? And I've got lots of videos in my 8th grade playlist that can help you if you're really confused, okay? All right, I'll see you next video. We're going to move on to the next unit. Bye.